This, we looked at the outside of the rock. When you look at the outside of the rock with this instrument, you can't be certain what you're seeing. You might be seeing a coating on the outside because the instrument can't see very deep into the rock. But we brought with us a grinding tool, a device called the rat, and we found even more sulfur. We found an enormous quantity of sulfur in this rock, too much to explain by any other mechanism, we believe, than this rock being full of sulfate salts. That's a telltale sign, we believe, of liquid water. And then I think perhaps most compellingly of all, once we put that rat hole in the rock, we looked at it with our Mossbauer spectrometer. And in those Mossbauer data, we found compelling evidence for a mineral called jarosite. That's a piece of jarosite here. It's an iron sulfate hydrate. This is a mineral that you got to have water around in order to make it.
If I look at our payload and I try to imagine what would it be like if we took one piece away, if we didn't have the Mossbauer spectrometer, if we didn't have the resolution or color capability of PanCam, we didn't have that arm with that ability to put us exactly right where we need to be. And I don't see the story coming out like it has if we take a part away. Every piece of this payload and rover has made a contribution to this story.
Sol 65, March 9, 2004. Spirit closes in on Bonneville Crater. The science team begins hanging out in surface ops, anxious to see the latest images.
If everything goes according to plan today, we should drive up to the very top of the crater rim and be able to see down into the crater.
Right about here. Right.
Has the potential to be a cool day.
Waiting for the picture. We'll see how far she went.
But they weren't quite close enough. Next day, they're finally on the edge.
Looking at that view right there, it looks like an awful lot of soil, an awful lot of the same stuff we've been looking at. We really got our hopes up that we'd peer down into this crater and there'd be dark, coarse-grained sands for mini-tests to look at.
No bedrock, no outcrop, no treasure trove. Still no hole-in-one for Spirit.
It's time for us to hit the road again and go to the East Hills.
They head off round the rim, hoping the far-off hills, if they can only reach them, would finally justify landing here in Gusev.
There is something very neat about those hills. Those hills are probably the oldest reachable landform in the landing site where we are at.
You see what appear to be terraces along the flanks of those Columbia Hills. How they formed, I don't know, but they're terraces or ledges. There's a lot of stuff starting to come out, and we're still 2.5 kilometers away from there. As we get closer, we're going to see more and more detail and structure. And I think if we get there, that the Gusev mission will take on a whole new light.
En route, they sample a lighter-colored rock called Mazatzal, which many thought might be something other than the dark basalt. Again, hints of water, but no smoking gun. Even so, some of the science team wants to linger over every white rock.
It's just like a elusive ghost, like Moby Dick, you know, chasing this white whale through the 7 seas. There's really, we haven't seen anything new at Gusev. It's all chunks of basalt with varying degrees of dust on it.
Meanwhile, the Opportunity team was back at work. Job 1 was to find out what those blueberries were really made of. Andy Knoll suggested returning to the berry bowl, a natural depression where the tiny spherules had rolled together. They used the rat to brush away dust, to get a clean reading of what the berry bowl was made of. Then with the APXS and Mossbauer, they compared that area with the blueberries right beside it. APXS measurements showed the berries were made of hematite, the mineral that was the reason they had come to Meridiani in the first place.
We're not done with the hematite story. Hematite covers the plains as far as the eye can see, hundreds of kilometers.
The second open question was perhaps the most important of the entire mission. Were the outcrop rocks laid down in liquid water? Grotzinger devised a mini-campaign of close-up observations covering Last Chance with more than 100 MI images. They were on the trail of telltale patterns, familiar from terrestrial geology. These Australian rocks date from 3.5 billion years ago. probably close in time to the Eagle crater outcrop on Mars. Today, this is desert, but the rocks tell the story of a different time. In close-up, you see patterns, intersecting, upward-facing curves. Geologists call these crossbeds. This is how they're made. Gentle waves, long ago, leave ripples in the sand. The fossilized patterns are evidence that liquid water in a